Hello guys, how are you? This is Dev. Today we are going to learn about graphs. Okay, this is a very important topic because questions are asked from this topic in the exam. Okay, we start from first x and t. Okay, the graph of x and t can be anything. For example, this is x and this is t. This can be a straight line. What does this straight line mean? First of all, this straight line means that the slope is constant. This means dx over dt is the slope. Why? Because this is theta, and if we take a very small element here, this is dx and this is dt, so tan theta would be equal to dx over dt, and tan theta in a graph is known as m, which is a slope. Okay, so we see here line is straight, so m is constant over here because theta is constant. Since theta is constant, tan theta is constant, hence m is constant. So v, since x is displacement, v is constant, velocity is constant over here. And now since velocity is constant, so dv by dt, which is the acceleration, is 0 over here. So in these types of graphs, acceleration is 0, velocity is constant. Okay, all right, another graph can be like this. For example, this is t and this is x. All right, for example, this graph can be like x equal to alpha t square, since this is indeed a parabola. Okay, so first of all, you see velocity here is not constant. Okay, because dx over dt would be equal to 2 alpha t. So we can see that t is varying. We started from 0 and it is varying around every point. Because of t varying, x will vary because of this equation. Okay, and since dx by dt is v, so you see now if we draw the v versus t graph from this graph, how can we draw? We see v is 2 alpha t, so v and t, we see that this is a straight line. Okay, if v versus t graph is drawn, we see that it is a straight line with slope 2 alpha. All right, so we see that acceleration, which is dv by dt, is equal to 2 alpha. So we conclude that slope of xt graph is v. All right, and slope of vt graph is a. Very important conclusion. Okay, so another point I want to highlight here is that this particle or person is accelerating in a positive not in the positive direction. Actually, it is accelerating, its acceleration is increasing. Okay, because actually I'm sorry, acceleration though is constant over here. Acceleration is not increasing, acceleration is constant, only velocity is increasing. Yeah, okay, only velocity is increasing. All right, so for example, had it been x versus t, if x was, you see, alpha t cube, then the graph would have been like this. All right, the graph would have been like this. Now dx over dt would be equal to 3 alpha t square. Okay, this means the velocity time graph is like this, and then since v equal to 3 alpha t square, dv by dt would be equal to 6 alpha t. Now we see that acceleration is continuously increasing. This means this particle is accelerating. All right, this particle is accelerating because time cannot go negative, so this graph will be omitted because t will start only from positive now. So this graph will be omitted over here in classical mechanics. Okay, now for example, if I give you a vt graph, say it is a triangle. Okay, this coordinate is t0 and this coordinate is v0. Alright, first of all, we have to find out the distance. Alright, first of all, you have to find out the distance. How will you find out the distance? It is very simple, since this is a right angle triangle. So distance is the area under VT graph. Always remember, distance is the area under VT graph. So what is the area? Half V0 T0. This was very simple, huh? Now we make it a little bit more complicated. Okay. So for example, this V versus T. Alright, this is T0 and this is V0. So now how will you find out the distance over here? Well, obviously we will have to calculate the area of this parabola. Say for example, V would be alpha T square. Okay. So the area of a parabola or area of any damn curve, VT graph, in VT graph would be equal to VDT. Alright. 0 from 0 to T0. Okay. This is X. So if alpha T square was V, then we can substitute it. This is basic integration. Alright. You should all know it. If you don't know it, you will never pass. Okay. This and putting the limits, this is very essential. X would be equal to alpha T0 cube by 3. This is the answer. Alright. If we have put the limits, if we did not put the limits, for example, we carried out simple integration like this, then this would have been alpha T cube by 3 plus C. Now, plus C is added because limit is not here. For example, now plus C is added because limit is not here. Alright. If we had to put limit, then C would have gone. Okay. Alright. So when the graph is like this, when the graph is in the positive coordinate, now how will you find out the displacement? For example, this in this particular graph, we had to find out the distance. Now we have to find out the displacement. So you see, this is a positive coordinate and distance and displacement would be same. Alright. So here distance will be equal to displacement. Alright. So displacement here would be equal to V0 T0 by 2. Alright. But say the graph would have been like this. Now these two are V0 only and velocity can go negative, so minus V0. This is T0 and this is 2T0. Alright. Now we are to find out the distance first. Alright. Now if we are trying to find out the distance, okay, we have to take the positive magnitude only. For example, the area of this triangle is A1 and A2. Then the distance would be A1 plus A2, right? We will have to take the modulus of A1 plus A2. Alright. This means area of A1 would be equal to half V0 T0. Area of A2 modulus we have to take. This will be equal to half V0 and T0. So V0 T0 would have been the distance, not the displacement. Okay. So in calculating the distance, we simply add the area. Alright. We take the magnitude and simply add it. We don't do anything. Okay. But for displacement, we can't do like this. For displacement, we have to take in account the sign of the velocity because particle has reversed now. Alright. This means the particle has reversed. For example, in this problem, this means that particle is going with a velocity and T0 it reached some distance x. Alright. And then reversed it because velocity here is minus V0. This means it has come back to the original point and taken time 2T0. Okay. So we see that point A to B, then B to A. Distance would be x plus x, but displacement would be 0. So here I have taken the area equal, but it can be unequal. So you will obviously have to minus it. Alright. This means the area of A1 would be equal to V0 T0. Area of A2 would be equal to minus V0 T0 by 2 if we are to take the displacement. So displacement here is 0. Alright. This is very important concept and you have to know it. Okay, similarly, if we have an xt graph, okay, and this is a line, this is obviously a straight line. Now, for example, we write x equal to alpha t plus c. Whatever be the graph, whatever be alpha, okay, obviously alpha is negative because the curve, the line is sloping down. Alright, so we take, for example, x equal to minus 2t plus c. Now you can neglect c. And what is the velocity now? Obviously dx over dt equal to minus 2. This means velocity is negative over here. This means how will we draw the vt graph? From vt graph we will draw like this. Minus 2, because it is constant, time will always go positive. Just remember, time is always positive. It cannot be negative. Alright. V can be negative. If x is displacement, then it can also be negative. Alright, what is the acceleration? It is 0. So we draw the at graph also. This is like this. It is on the t line because it is 0, always 0. And this is like this, okay. So from xt graph, you can derive vt graph, and from vt graph, you can derive at graph. This is very important, and you know, this comes in a lot of exams. Matlab, whatever you are planning to do, just, you know, you should know this. You should know this by heart. How to draw xt graph, then how to draw vt graph, then how to draw at graph, okay. For example, if I had to reverse it, alright, for example, this is vt. So if this is a straight line and this is v naught t naught, so the area under this is v naught t naught by 2. Alright, this is a distance. So since this is a constant, alright, now this is a straight line, okay. So how will we draw the xt graph? How will we draw the xt graph? First of all, this is the total distance, alright. This is not the minuscule distance the particle has traveled, alright. This is the total distance. So for minuscule distance, we can see that the relation between v and t, v can be alpha t, okay. This is v naught comma t naught. First of all, we have to obtain the relation between v and t. Now we can apply for x, v dt. This is going from 0 to t, yes, but we need not take the limits right now. We should not take the limits because we are trying to draw a graph between x and t. So just normal integration will suffice, alpha t square by 2. So you see, this is the graph between x and t. Okay, since the particle is stopping at t naught, so only we have to do is this. Since the particle is stopped at t naught, so this is equal to x comma t naught. That's it. So this is the xt graph. Alright. V naught t naught by 2 was the total distance. Obviously here v equal to alpha t, so v naught equal to alpha t naught, and we can just substitute value of v over here. So this will be equal to x equal to alpha t naught square by 2. Alright. If we put the limit 0 to again alpha t naught square by 2. Alright, so this is the proper graph how we draw. Alright, and just simply drawing xt graph will do it, because you know, from xt we can derive at t. For example, we differentiated dx over dt. So 2 alpha t by 2, which is alpha t, and which was the original expression of v. So this would be the graph of x. Okay, don't draw a straight line. This is stupid. This is wrong. This will never be the graph of x. Sometimes people draw a straight line. This is not the graph of x, okay. So now another concept which I wanted to take is of the circle, okay. For example, if a particle, this is r, okay. If a particle, for example, you know, if a particle traversed half a circle, alright, with a constant velocity v, this is the ending point. This is half a circle only. Okay, for full circle, everyone knows, you know, for full circle, if a particle starts here and ends up here, displacement is 0, obviously. But for half a circle, particle has started at A and ended at B. So displacement will be from A to B. Alright. So it will be R plus R, which is equal to 2R. This is the displacement only. Alright. Yes, this is the displacement. Now what is the distance? Distance would be equal to the length of path traveled. Just remember, length of path is the distance. Length of path. You should just remember this. And what is the length of path? This length, which is half the perimeter, which is equal to pi r. Alright. Distance is the length of path. Displacement is the path between initial and final points. Alright. So we have here distance and displacement. Okay. Now I want to know what was the acceleration during the whole process. What was the acceleration of particle? So you see, acceleration in the time interval. For example, if the time interval was delta t of the particle, what was the acceleration? You see, final velocity minus initial velocity gives the, you see, Vf minus Vi by t. This is the acceleration. Alright. This would be the acceleration during the whole time t. So we can see this vector is down. For example, this we take negative j and this we take as positive j. So we have minus Vj by delta t. So we bring it here equal to minus 2Vj by delta t. This is the acceleration. Okay. This should be the acceleration. So what is the mean velocity? We also have to calculate the mean velocity. Alright. I'll show you over here. This is a semicircle. Everyone knows. Okay, if you don't know, I'll tell you. Mean velocity is the total displacement, okay, upon total time interval. So mean velocity is usually written like this, and total displacement over here is 2r and total time is delta t. So this is the mean velocity. Alright, what is the mean speed? Mean speed, tell me. Total distance by total time. Okay. What is the total distance? Pi r. What is the total time? Delta t. So this is the mean speed. This is the mean velocity and this is the mean speed. You see the difference between velocity and speed. Here it is very clear what is mean velocity and what is mean speed. So there is usually a difference, okay, when the particle is not in a straight line generally. Okay. Also earlier we found out the acceleration as 2v by delta t. Okay. Alright. Now this is velocity here. Just mind it. Okay. So putting the average acceleration, we get the mean. We can substitute the, you see, for the average acceleration we have. Okay. This v can be substituted here. We have, or we can substitute delta t 2v by 2r square. So we have a equal to v square by r. Alright. Now I take another question. Okay. For example, this is the ground. Particle is thrown up with an initial velocity u. Alright. This is the height h. It reaches the height h, okay, and in time we can say t naught. Let us suppose. Alright, first of all, I want to know 0 to t naught, this will be the time. Okay, if I want to draw the graph between v velocity and time, how will I do it? First of all, we have to take many things into account. First account is that there is downward acceleration g working on the particle. So obviously when we throw the particle from the point P, its velocity will get reduced. So the final velocity will be u minus gt from the first equation of motion. Okay, u minus gt. So we see u is constant over here. So we can draw the graph between v and t. We take t naught over here. Since u is constant, this means slope is only minus g, because dv by dt equal to minus d. This means acceleration is minus g, as we told earlier. dv by dt is a. This means particle was initially at u, okay, and it went down until t naught. Its velocity became 0. All right, because particle momentarily stopped over here. Okay, particle had momentarily stopped over here, and t naught was u by g, because at t naught v will be 0. Okay, now particle goes down. All right, particle goes down. So here its velocity is 0. So it will take a fresh start. Okay, since it will go down, it will then its velocity v would be equal to 0 plus gt, because it is starting from a 0 velocity here, as it is already attained 0 velocity by stopping. Okay, so this means here velocity is gt, simply gt. Okay, since the velocity is simply gt, then because the time interval will be taken same, so we can take it will be t naught only, and this will be the graph. All right, this will be the graph. Okay, and since time taken will be t naught only, so final velocity would be equal to g t naught, and g into u by g, final velocity will also be u vf, sorry. All right, so this is the total graph. Now can you tell me from this graph how will we determine the distance? Obviously, just take the area and add. Just take and add. Okay, this is okay. First of all, I made a mistake here, because I have taken velocity positive, and otherwise the particle is going down. I have to take the velocity negative. Sorry, this is a major mistake I made. Actually, this was correct. Okay, this is 2t naught. Particle will go down. Time will not go back. Time cannot go back. Time only can go forward. All right, this is the correct graph, because particle has gone up. We have taken the velocity versus time graph. So velocity has direction also. We have to take the direction into account. Okay, this velocity is positive. Okay, hence this quadrant. But when particle comes down, the velocity is negative, hence this quadrant. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. I hope you know, in first quadrant both the coordinates are positive. In the second quadrant only the x is positive, only the x is negative, y is positive. In third both are negative, and fourth only x is positive and y is negative. Okay, now can you tell me the distance? From this simple graph we can calculate the distance. Okay, this was h. Suppose this is h. Okay, this was u minus u. Distance would be simply a1 plus a2. This means, what is this t naught? This is u na, half u t naught plus half into u into the difference to t naught minus t naught is t naught. So u t naught is the distance. U t naught is the distance. Okay. Okay, I will calculate distance now from the other method also. Okay, then the concept will be clear. Suppose this is h, this is u, and this time t naught. Obviously, v would be equal to u minus gt, yes. Then v dt would be equal to u minus gt times dt 0 to t naught, okay. Obviously this is h, this is h, u t naught minus g t naught square by 2, okay. This was h. Now we know the value of t naught because v equal to u minus gt, v would be 0 at t naught, so u by g is t naught, right. Substitute t naught over here, u dot u by g minus g dot u square by g square into 2, okay. H equal to u square by 2g, alright. H is u square by 2g. Now this h is u square by 2g. Now particle also is coming down, okay. It is not only hanging up around, okay, it is coming down. This means this will be 2h, so u square by g. This is the total distance. Now what was the distance we calculated? U t naught. What was t naught? U by g, u dot u by g. This is equal to u square by g. So this is in conformation with the original equation of motion, hence the graph is in conformation, okay, and the graph is accurate. Also this is 2 t naught minus u a1 a2. Now what is the displacement? Just by simply seeing we can obviously calculate the displacement. From P it has gone up to A and then come back to P. Obviously any layman can tell displacement is 0, alright. But from graph obviously displacement is 0 because A1 is equal to u t naught, but in case of displacement A2 will become minus u t naught. So A1 plus A2 would be equal to 0, alright. These are the concepts, these are very important concepts. मेडिकल एग्जाम में और इंजीनियरिंग एग्जाम में ज़रूर पूछे जाएंगे, 100% आई नो, ओके. सो नाउ वी स्टडी द एवरेज वेलोसिटी. Average velocity is v, okay. This is a sign for average. It is the total displacement divided by total time taken, okay, as I had explained earlier. So let's do a problem. For example, particle starts at A. Total distance, you can assume anything. I have assumed x. So the problem says that the particle covers half the distance with a velocity v naught, and next half of distance and the rest of distance, say, is covered with the velocity v1 for half the time and v2 for another half of time, okay. So say the particle covers qb in time t, okay. So for half the time t by 2 it has covered the distance with velocity v1, and another half the time it has covered the distance with the velocity v2. So for this half of the time the total distance traveled is v1 t by 2. For this half of the time total distance traveled is v2 t by 2, and the whole total distance, this would be equal to qb, right. So qb would be equal to x over 2. This would be equal to v1 plus v2 into t over 2. This cancels out, alright. A q b v1 for half the distance. So what is the time here for AQ? Or we can say the distance x by 2 v1 into, sorry, this was v0 into t1 say, okay. So what is the average velocity? It is the total distance, which here is x. So x divided by total time, this would be t plus t1, okay. So x divided by what is t? X upon v1 plus v2. What is t1? X divided by 2v0, right. X cancels out. So we have the magnitude of average velocity as 2v0 into v1 plus v2 divided by 2v0 plus v1 plus v2, okay. This is the average velocity. All right. Suppose now, suppose V varies as V naught sine omega t. All right. First of all, I want to draw the graph of this. This is very simple. Sine graph, everyone knows. Okay. This is t and this is V. This is 0. I am not teaching maths, so you should know what is sine graph. Okay. Now at t equal to 0, V will be 0. This is because sine 0 is 0. All right. Then it will reach a maximum at omega t equal to pi by 2. So it will reach a maximum at t equal to pi by 2 omega. So this maximum would be equal to pi over 2 omega. And then it will again be 0 at pi over omega. Then it will go down. Okay. Then it will reach a minima. Obviously sine has to reach minima. This would be equal to 3 pi by 2 omega. And again this will be 0. This would be equal to 2 pi by omega. Okay. This is because 3 pi by 2 omega would be equal to pi omega plus pi by 2 omega. Or we can say, sine pi plus pi by 2. Sine A cos B plus cos A sine B is equal to minus. So yes, this is the graph. Okay. All right. This is maximum value V naught. So in this graph, first of all, V is varying like this. Now we have to calculate the distance. How will we calculate the distance? These are two areas, A1 and A2. We will take the positive magnitude of these areas. So for example, the first area, V dt would be integrated from 0 to pi by omega. This would be equal to V naught integration 0 to pi by omega sine omega t. All right. Okay. All right. Just wait. Yeah. 0 to pi over omega V naught sine omega t dt. This would be the area A1. And again, you see the integration from, 0 nahi hai, pi by omega to 2 pi by omega sine omega t dt. This would be area A2, right? This is because we are taking different areas A1 and A2, right? This is pi by omega, this is 2 pi by omega, this is V naught. So what is this? Obviously sine omega t dt is cos omega t by omega 0 to pi over omega, right? And because differential of cos is negative, so integral of sine will have to be negative. Why? Because d over dt cos omega t, this is equal to minus omega sine omega t, right? You take dt over here and you integrate. We get cos omega t by omega minus equal to integral sine omega t dt. This is the answer. Okay. So this is what? We can take V naught by omega outside, and omega may cancel out. Cos pi is minus 1, then again minus 1, then this is 2. So this is 2 V naught by omega. Okay. Now what is this? This was pi over omega to 2 pi over omega V naught sine omega t dt. Okay. So this would be equal to V naught by omega. This would be negative cos omega t. Again, this will go from pi over omega to 2 pi over omega. Now, what is the answer? Okay. So, what is the answer now? The answer here is V naught by omega negative. We can take it out. Cos 2 pi is 1. Minus of minus 1. This is equal to 2. So minus 2 V naught by omega. But remember, we have to take the modulus of A2. So A2 mod would be equal to 2 V naught by omega, right? So now the distance would be equal to 4 V naught by omega. This is the total distance in this graph, but displacement, that is A1 plus A2, would be equal to 0 because A2 is negative. Alright, so distance is always positive, displacement can be negative. We have seen from here distance is 4 V naught by omega. Now in the same equation, we have to find out the average velocity. How will you find out? Well, average velocity we have to find out, right? From where to where? First we have to specify from where to where we have to find out. Suppose I want to find out the average velocity. Suppose I first take 0 to pi by omega. In this interval of time, I have to find out the average velocity. Okay. So in this interval of time, what we do is, obviously average velocity is total displacement by total time. Yes. So 0 to pi by omega v dt by total time would be equal to 0 to pi by omega dt, right? This was, as we earlier calculated, 2 v naught by omega, and this is pi over omega, right? So this is equal to 2 v naught by pi. This is the average velocity from 0 to pi by omega. Now, for example, if I want the total average velocity from 0 to 2 pi by omega, this would be 0. As we can see, the total displacement was 0, right? The total displacement from 0 to 2 pi by omega was 0. So average velocity has to be 0 because it is total displacement by total time. Since it was 0, so it is 0. Okay, but we can also prove it. V naught sine omega t. So V naught sine omega t dt 0 to 2 pi by omega by integration 0 to 2 pi by omega dt, right? This is the average velocity. What was this? V naught by omega minus cos omega t 0 to 2 pi by omega by 2 pi by omega. What is this? Now omega by cancel out, cos 2 pi minus cos 0 minus V naught by 2 pi. Cos 2 pi is 1, cos 0 is 1, so V is 0. So just I wanted to tell you that, you can solve the equation through graph. Okay. No need to carry out such huge integration. In earlier sine graph, we could have easily calculated average velocity from 0 to 2 pi by omega to be 0 without going through any integration. If the areas are equal, obviously when one is positive, one is negative, they will cancel out. The total displacement will be 0. Hence, the average velocity will be 0. Another problem is that, for example, V naught sine omega t is V. Then find out the average acceleration. What is acceleration? You see, acceleration is the change in velocity by time. Okay. Now, average acceleration, obviously average velocity by time, right? Another way to calculate, this is the graph, right? V was V naught sine omega t. This is the graph, right? I want to draw AT graph, just differentiate it. V naught omega cos omega t. So, earlier this was V naught. Now we draw the AT graph. Because it is cos, so V naught omega. Alright, then cos descends. Because cos descends, so here, this is the graph of A, right? What is this? This would be pi by 2 omega. This would be 3 pi by 2 omega. This would be 5 pi by 2 omega. Alright. Yes, because 2 pi by 2 omega would be pi by omega. Omega cancel out, cos would be minus. So this would be pi by omega. Okay, this would be 2 pi by omega. And so on. So for example, I have to find out the average acceleration from 0 to 2 pi by omega. Just integrate it. This would be the average acceleration. Okay. So what is it? V naught omega cos omega t, omega would be denominator, omega cancel out. So this would be equal to V naught omega by omega sine omega t and 0 to 2 pi by omega by 2 pi by omega. When we put the limit here, omega cancel out, sine 2 pi minus sine 0. This is 0. So average acceleration is 0. Okay. Average acceleration from 0 to 2 pi omega is 0. Alright. So we could have calculated the acceleration by an easier method also. You see, acceleration A is final velocity minus initial velocity divided by the time interval. Time interval is of 2 pi by omega. We see at 2 pi by omega velocity final is 0 due to the graph, and at 0 it is also 0. So we see A would be equal to 0 minus 0 by delta t. This would be 0. Okay. So we need not go through the arduous and difficult integration. We just can solve simply from the graph. Okay. Now I want to take up a problem. For example, this is a cylinder and this is a point P. Okay. Now I roll over the cylinder. Cylinder is going with the velocity v and rolling with the angular velocity omega. So one basic concept is that v implies omega r. Okay. R is the radius of cylinder. Okay. So when I rolled over the cylinder, the point P moves and the cylinder also moves. And after complete revolution, P comes back to the ground. Alright, so I now want to find out P. We can assume this as P dash. Okay, this is O and this is O dash. So now I want to find out the displacement of P. Displacement PP dash. Because displacement, obviously final position and the initial position, the straight line distance between them is called displacement. Okay. So we see that the cylinder has moved 2 pi or 360 degrees. In moving 360 degrees, it has covered the circumference of itself. So this means when it was moving on the ground, it was covering the same distance of circumference. So the displacement of point P is 2 pi r. Okay. Displacement of point P is 2 pi r. Alright. Now another question arises. What is the distance covered by point P? From P to P dash, what is the distance? Now distance will not be same as displacement. We now consider this figure. P moves a little bit to Q. Alright. In this movement, first of all, this particle is going along with the cylinder translationally. Right. So this particle at Q will have a velocity v along the direction x. Alright. But at the same time, it will also have an angular velocity, or we can say a tangential velocity v, where v would be equal to omega r. Alright. For smooth rolling, this would be omega r. Alright. Now we know that distance is speed into time. Distance is not velocity into time, that is displacement. Alright, distance is speed into time. Now we have to take the speed. What is speed? Speed is the magnitude of velocity. Now first we will take the magnitude of velocity over here. This is very easy. This is the point Q and this is P. This is somewhere center. This is the velocity v. Alright, this is velocity v, and say this angle is theta, right? This is 90 degree, this must be 90 minus theta. We split the velocity into two components, along x and along y. Now this is theta, this is 90, this is 90 minus theta, this is theta, and this is 90 minus theta. Alright, so this must be theta. So we split the components. So this is j and this is I. So the net velocity vector would be equal to v I minus v cos theta I, because this is theta, so this would be v cos theta, and this would be v sin theta, right? So plus v sin theta j. This v would be equal to v 1 minus cos theta I plus v sin theta j. Now we have to calculate the modulus of this. Modulus of v would be equal to root under v square 1 minus cos theta whole square plus v square sin square theta. This would be equal to root under v square 1 plus cos square theta plus sin square theta minus 2 cos theta. Right. This would be equal to v square, cos and sin will be 1. Alright. So this would be 2 into 1 minus cos theta, the whole root. This would be equal to v square dot 2 times dot 2 sin square theta by 2. I will not explain how this comes. 1 minus cos theta is 2 sin square theta by 2. You should know. This would be equal to 2v sin theta over 2. Alright. Now we can calculate the distance s. This would be equal to ds would be equal to v dt, and we can integrate this. This is 2v sin theta by 2 dt. Now since it is traveling with an angular velocity omega, we can see that theta is omega t, right? So d theta would be equal to omega dt. So we just divide omega and multiply omega. This would become d theta. So 2v over omega sin theta over 2 d theta. Now it has traveled 360 degrees because the point P is on the ground now again. So this would be equal to 0 to 2 pi. Now we can integrate this easily. This would be equal to cos theta by 2 negative by half, and we can put the limits as 0 to 2 pi. This would result in 8v over omega. And as we know that for smooth rolling, since v equal to r omega, so this distance is 8r. 8r is the answer. Okay guys, so I'm ending here, and if you have any doubts, please let me know. If you want me to make more videos, please let me know. Please let me know topics on which I can make. If I have left out any topic, please remind me. I'll make on that too. Okay, subscribe, like and comment. Thank you.